Hello friends, in today's question, a circular disc of radius r and mass 9m, a small disc of radius r by 3 is removed from the disc. The moment of inertia of the remaining disc about an axis perpendicular to the plane of disc and passing through O is. So we have a big circular disc of radius r and mass 9m, and from which a smaller disc of radius r by 3 is removed, and then we have to supposed to find out what will be the moment of inertia of the remaining disc when the small disc has been removed. Okay. So first let us consider the original disc, that is a complete one. And this is the center, and it is given that its radius is r, and this is having a mass of 9m. Therefore, the axis which will be perpendicular through the plane of this, so it will be passing through this center, and let us suppose it is going inside the center and mark with the cross. Therefore, let us say for moment of inertia for the original disc, and for the original disc the radius is given as r and mass is given as 9m. Therefore, you can say moment of inertia for original disc passing through center and perpendicular to the plane of the disc. This can be written as, let us suppose it's given as I original, and its formula is 1 upon half mass into radius square. In this case mass is 9m and radius is r, therefore we can say our I original is equal to 1 by 2 9m and r square. So this comes as 9 by 2 mr square. Now let us find out the moment of inertia for the removed disc. Moment of inertia for removed disc. So this is our removed disc, and this is a center, and in this case also we assume that the axis is perpendicular, that is represented as a cross. Here the radius is given as r by 3, and mass we can calculate. Okay, so it is given that radius is equal to r by 3, and for mass will be given as the total mass, that is 9m, multiplied by the area of the removed disc divided by the total area. Area removed divided by total area. So let us say this mass is given as small m. So small m is equal to 9m, and area removed is our pi r by 3 whole square. Total area is pi r square. So this comes as 9m, and here pi goes with pi, and r square will be cancelling with r square, so this will be multiplied by 9. 9 goes with 9, and this comes as m. So mass of the small disc is now capital M, Therefore, we can say that moment of inertia for removed disk, let us suppose that is given as I removed, the formula will be same. It will be half m r square, and the mass is m. So let us say this will be coming now as I removed is equal to half into m, and radius is our r by 3 whole square. So this comes as 1 by 18 mr square. Now we have to find out the moment of inertia for the remaining disk. So let us redraw the figure again. So this is a complete disk, and in this complete disk there is a small disk of which the area has moved, and this is a center of two disks. Let us first of all find out what will be the distance between the two centers. So let us suppose d is the distance between the two centers. So we can say d will be equal to total radius r minus radius of small disk, that is r by 3. So this d will be coming as 2r by 3. Now we are going to use theorem of parallel axis so that we can shift the moment of inertia to the original disk center. Okay, let's suppose this is given as O. So here we have two axes, both are perpendicular to the plane, and in this case we assume that, let us suppose for the sake of convenience, they are into the paper like this. So both our disks are parallel with each other. Now we are going to use theorem of parallel axis and shift the moment of inertia of the small disk to the original disk. So theorem of parallel axis to shift the moment of inertia to the original disk center O. Okay, that's why we found out the distance between the two parallel axes. And in this case, you can say that I removed, but now with the center O, its moment of inertia will be given as, it will be I removed, that moment of inertia of the removed disk plus the mass and the distance square, that is distance between the two axes, perpendicular distance. So I removed, we already know, is 1 upon 18 mr square. Mass is mass m, and it is 2r by 3 whole square. So we get that I removed now with the center O is equal to 1 by 18 mr square plus this will be coming as 4 by 9 mr square. We get I removed with the center O is equal to 1 by 2 mr square. Therefore, the moment of inertia for the remaining disk, moment of inertia for the remaining disk let us call this as I remain, and we can say our I remain is equal to I original minus I removed with the center O. Substituting the value, I original is 9/2 mr square minus this is 1/2 mr square, which will be coming equal to as 8/2 mr square. Therefore, we get I remain is equal to 4, this goes by 4 mr square. So this is the moment of the remaining disk. This is moment of inertia for remaining disk. Now if we check the options, option A is the correct option. Therefore, we can say that option A is correct. So this completes the question. Thank you.